Hi everybody, lesson 2. Lesson 2 in the IB year is all about domains and ranges. Domains and ranges were a big topic in Algebra 2. We also deal with it in the IB course because you have to know where you're going and you have to know where you are coming from. The domains are the x's, where we're coming from. The range is the y, that's where we're going to. And that's our discussion topic for this lesson. Two definitions. The domain of a function. The domain is the set of all first coordinates. The set of all first coordinates. The range is the set of all second coordinates. Second coordinates. If you remember from an Algebra 2 course or what have you, the first coordinates are the x's traditionally. They don't have to be x's. They could be time values. They could be height values. They could be letters. They could be whatever. But the first coordinates, those are your inputs, those are your domain. And the second coordinates, those are traditionally your y values. In this course, almost exclusively, they are the y values. They're the values on the vertical axis. I should point out the biggest word in either of those definitions. The biggest word in either of those definitions is set. When we give a domain or a range, we are giving a set. We are giving a list of or a rule to find first coordinates and second coordinates. So in a discrete case, no big deal. In a discrete case, you've got 1, 4, 7, 2, 5, 8. This is a function like so. Every x goes to 1y. Every x goes to exactly 1y. When we ask for the domain is the set of inputs. And the set of inputs is the set of 1, 4, and 7. The range is the set of outputs, the set of numbers that have an arrow headed toward them, 2, 5, and 8. Now, quick side note here. So I've got, I don't know, 2, 4, 6, and I've got 1, 3, 5, 7. And 2 goes to 5, and 4 goes to 3, and 6 goes to 5, like that. That's a function. Every x goes to 1y. Every x goes to exactly 1y. So the domain is 2, 4, 6. But the range is only the set of numbers that has an arrow pointed toward them. 3 and 5. 1 and 7 don't have an arrow pointed in their general direction, and so they are not part of the range. Now, domain and range is easy in a discrete case. Domain and range gets a little bit more tricky in the graphical case. So we think about a function like y equals x squared. Very straightforward function. Y equals x squared. So we want to know what are all of the possible x values that could be generated with y equals x squared. Well, all the possible x values, I can't imagine any x value that doesn't get, I just can't. I'm trying to think about x values that would not work, and there aren't any. So if we want to think about it differently, we imagine that at the top of the y-axis, way up there, is a gorilla shining a flashlight down. And when it shines a flashlight down, the red function here, this red function, the red function casts a shadow on the x-axis. I mean, it blocks light. So where does it block light? Well, it blocks light all the way this way, and that arrow on the end of the parabola means that that keeps going. And it blocks light all the way through here, going like so. If that gorilla is shining a flashlight, that parabola is blocking an awful lot of light from getting through to the x-axis. So I need a way to say every x value is okay. Every x value is okay. And there are two ways to do that. One, we can say that the domain is the set of all x such that x is an element of the real numbers. Set of all x such that x is an element of the reals. Domain is a set. You have to give an answer as a set. And this is proper set notation. The other way to do this is to use what's called interval notation. If we look at the shaded area on the number line, shaded area on the number line is basically one long interval. And that interval starts way over on the left at negative infinity, and it goes way over on the right to positive infinity. And we say round brackets on the outsides because negative infinity is not included. I mean, you can't get to negative infinity. And positive infinity is not included. You can't get to positive infinity. If positive infinity could be included, we would use a square bracket on that end. Okay, well range, the range, I think to myself, if there was a chicken at the ends of the x-axis shining a light, chicken shining a light from the right side, chicken shining a light from the left side, the parabola would block light all the way through here. The parabola would block light all the way through there. Those are all the y values that get used. So how do we say that? Well, it's the set of all y such that y is greater than or equal to 0. It's the set of all y values greater than or equal to 0. Or we could say that that is just one long interval. And that interval runs from 0 all the way up to infinity. Smaller number on the left, bigger quasi number on the right. We go from 0 to infinity. 0 is included, so we're going to put square brackets on that end. Infinity is not included. You can't get to infinity. Infinity is not a number, so we put parentheses on the right side of infinity. That's domain and range. Well, what happens if you have this scenario? Y is square root of 5 minus x squared. Y is square root of 5 minus x squared. Looks sort of like that, kind of hard to see. There, much better. And I'll square up the viewing window. That thing is a semicircle. That thing right there is a semicircle. I'll blow it up nice and big for you. This thing is a semicircle. And it runs from here all the way around to here. It's a semicircle. You can tell because if you square both sides and do a little bit of algebra, you get the equation of a circle. We don't get the bottom half of the circle, so we don't have a plus or minus in front of the radical, and a radical always calls for a positive square root. So that's our graph. I want to know domain and range. Well, the domain, if I've got the gorilla shining a flashlight from the top of the y-axis, gorilla's shining a flashlight, we've got shadow all the way through here. Well, what's that domain? That domain is a set of x values. It's a set of x values such that Somebody is less than or equal to x is less than or equal to somebody, but how do I know where those places are? Well, that circle is centered at the origin. It's got a radius of radical 5. Radical 5. That's a radical 5. That's a minus radical 5. Like so. Or we could say that the domain runs from negative radical 5 to positive radical 5, and both of those numbers are included. The graph does get to negative radical 5. The graph does get to positive radical 5. Range. Range is a set of all the y values. If I have a chicken shining a flashlight from the positive x-axis, from the end of the positive x-axis, there's going to be shadow cast all the way through here. And that shadow is going to take in all y values such that 0 is less than or equal to y is less than or equal to radical 5. Or, if you like, 0 to radical 5. 0 to radical 5. Now, if you're taking an IB course, then you know that you may have a calculator available to you for part of the time. And so you may say, okay, I want to find a maximum. So I'm going to find a maximum. I'm pretty sure that may be the max, but just to make sure, I'm going to go to the left of it, and I'm going to go to the right of it, hit enter, and then one more time, and I get the maximum. Now that E minus 7 thing that's over here, this E minus 7 thing, that means times 10 to the negative 7. When you see that, the calculator is trying to tell you 0. Now, since this is IB, this y value here, how many decimal places do we have to report that to? We're going to report that number to 3 significant figures. When we report a decimal in an IB math course, we do it to 3 significant figures. So the first non-zero digit is the first significant digit, and then we write 2 more, rounding correctly. So we could say that the range of that function is from 0 to 2.24, and that's how we would leave it. If we're doing AP, it's 3 decimal places. We're doing IB, so it's 3 significant figures rounded correctly. Okay? Okay. So to find domain, you've got to consider the set of all possible x values. To consider range, you've got to find the set of all possible y values. So for you to consider, before we gather next time, I want you to find the domain and range of the following. Y equals x minus 3 over x minus 1, because that's going to be a nasty picture. Y equals radical 9 minus x squared minus 2, and y equals radical 16 minus x. And the reason I picked these are plain Jane simple. This guy, you've got to take a look at a graph to see the range, because we haven't studied rational functions in depth enough to know that. But you can find domain rather quickly, because we know that a denominator can never equal 0. And so when we're considering domain, we just look to see, oh, there's a denominator. The denominator can never equal 0. I picked 2 radical functions because when you have a radical, your radicand, the thing that's underneath the radical, has to be non-negative. And so in each of those cases, we could find domain algebraically by setting the radicand greater than or equal to 0. And then we do some algebra from there. So those are things you should come to class ready to talk about. You know what a domain is. You know what a range is. You have some basic algebraic understanding and some basic graphical understanding. Time to put it to use. All right, everybody. Thanks very much. See you soon.